What's up, YouTube? We are coming back with another 2+ hours of web application hacking material. Now, we recently modernized the content that we have on the PAH course, the Practical Ethical Hacking course, and we added new content for the web application section. These are all custom labs that we built out, and we just wanted to get away from the dependencies that existed with using the old videos. Now, the old videos rely on open source material. Open source material can change, so we wanted to be able to control our own narrative. That doesn't mean that these videos aren't valuable and that they shouldn't be consumed. There's a lot of great information in this video about web application hacking, and I hope that you digest it and you take this offering and you learn something from it. So we're going to cover the OWASP top 10. We'll talk about SQL injection, cross-site scripting, how to use Burp Suite, talk about XXE attacks, and a bunch of other fun stuff. So hopefully you enjoy the video and you enjoy the content. If you do, please do consider subscribing to the channel. If you're interested in learning more about ethical hacking, please feel free to check out the Practical Ethical Hacking course that we just showed. I'll add a link in the description below this video. With that being said, we're going to take a quick word from our sponsor, and then we're going to jump right into this course. Thank you so much. Today's video is sponsored by NordPass Business, where you can get a 3-month free trial at nordpass.com/cybermentor using code cybermentor. Do you find yourself storing business credentials in spreadsheets? How about notebooks? Or even worse, sticky notes? What about being stuck in that vicious reset your password circle? There just ain't no time for that. With NordPass, forget about storing passwords in the weirdest places and resetting them when you can't find where you wrote them down. Save all of your passwords in one secure place and autofill them whenever you need, regardless of which device you're on. You can also share sensitive information like shared business account credentials between your colleagues safely. So what are you waiting for? See NordPass Business in action now with a 3-month free trial, again at nordpass.com/cybermentor. with code cybermentor. In this section, we're going to be testing the top 10 web application vulnerabilities. So these are based off of what is known as the OWASP top 10, that is OWASP, and we're going to cover these using a tool called Juice Shop, or a platform called Juice Shop, which is a vulnerable web app. So we're going to go through, we're going to install Juice Shop, and we're going to kind of just go one by one through these top 10. Now, this is a high-level overview with some hands-on experience. This is by no means an all-inclusive web application course. By itself, a web application course can be 20 to 30 hours. There's so much depth and things that you'll need, and I'm going to provide resources at the end of the course if you want to go deeper and learn more about web apps, but I want to give you that practical experience. When you need the top 10, which you're going to need to know for interviews, it's going to be important, right? So you're going to know the differences in all 10 of these, how to exploit them, what the exploits are, why they're vulnerable, and you're going to learn the defenses for them as well. Not all of these we're able to get hands-on with, but a good majority we are, and the rest are good to just talk about at a high level, a good theory type point of view. So we're going to go ahead and dive right in. We're going to start first with talking about what the OWASP top 10 are and the OWASP testing checklist. So I'll catch you over in the next video. Before we dive into penetration testing, I think it's super important to talk about the OWASP top 10 and to provide this checklist with OWASP that we're going to be using. And first of all, let's just talk about OWASP. So OWASP stands for the Open Web Application Security Project. This is the web app reference 101. I have no better way to put it. This is the go-to place when it comes to web application penetration testing. It's OWASP, and you're going to hear this all over the place, especially when it comes to web application penetration testing, and you're going to hear interview questions and all kinds of stuff related to this. So what I want you to do is I just want you to go out to Google and go to the OWASP website, explore around, see what's interesting here. The one thing I do want to point out is there is the top 10, and this is great right here. We can open this in a new tab. They also have this cheat sheet series that they're starting. So you can go into here and say you're looking for specific cheat sheets. You can look for cheat sheets on say cross-site scripting, which we haven't got into any of this, but it'll tell you, hey, here's all the different ways that you can test for cross-site scripting. Here's different payloads. Here's how to attack. And it's really nice. And they give you all different kinds of ways to attack. And, we're going to be covering the top 10 in this course, which here's the top 10. The top 10 being the what they consider the top 10 most popular weaknesses in a web application, and what any company or organization should be aware of. So these change from year to year. Right now, they are in the 2017 version of it. And you could just click on this here and kind of get an idea of what some of the top 10 are. Now, there are at least over 100 different ways to exploit a website, probably way above that, okay? And there's all different kinds of vulnerabilities that you can check for. The top 10 are considered the most critical. Now, these are what your potential employer, are probably going to interview you on, these 10 topics. And it's important to know what they are. You don't have to know specifically 1 through 10, have it memorized. It doesn't hurt. Sometimes in an interview, I've been asked, okay, what is the number 1 on the OWASP top 10? And you should know it's injection. But I couldn't tell you that security misconfiguration was number 6, for example. But you might have some of those trivia questions, but more than likely what they're going to ask you is, what is an XML external entity? How would you go about exploiting that? Okay, you've exploited it. Now, how would you go about defending that? How could you instruct a client to defend against this? And in my experience, being able to talk to developers is one of the hardest things, especially if you're not a developer. Previously, I was not a developer. I don't come from a development background. So when you're doing a web app assessment, you have to imagine the situation that you're in. You are attacking a website or web application that has been developed by people, and then you have to go face to face with those people and tell them what's wrong with their website or what's wrong with their web application. And they can become defensive, and it's very easy to, you're beating up their baby. It's their pride and joy and nobody wants to be, told that they've left flaws in an application or anything. So sometimes it can get combative, not to scare anybody away, but just to prepare you for those sorts of situations. So having a good understanding of what you are exploiting and why it's vulnerable, and also how to fix it, is super important, because that way you can just relay that to the dev. And the better that you are at talking about it, the more respect you're going to get in a room, and the less likely that there's going to be combativeness, because you're going to be able to hold your own against people that are developers. So with that being all of the way, we're going to be covering these top 10 here. And if you want, you can scroll through this and just read through the different top 10. It has them here and how it's changed between 2013, 2017, and come right through. And it gives you a high-level overview of all the different types of flaws. And you can come right to injection here. And it talks about the different types of injection, how to prevent it, is it vulnerable? And then it gives you all different kinds of references. Here's all the different types of cheat sheets that are available to you, and just the CWEs as well, which are just another thing to look at. Port Swigger is another thing to look at as well. There's all different kinds of things here. Example scenarios. So this is very, very well laid out, and it's just fantastic resource for anybody looking to get into web application testing. Web apps are overwhelming, but the more you read up, the more you study, the more you just keep into the times, the better off you're going to be. So with that all being said, let's go out to Google one more time or 2 more times here. And what I want you to download is this OWASP checklist. So go and just Google OWASP checklist GitHub. And this Tan Prathan here, this first one that comes up, you can just click on this, and you should be looking for an Excel sheet. And let me bring that up on my end. So this Excel sheet, I have witnessed firsthand save an assessment. And I'll explain that here in a second. But here you have a checklist. And if you scroll through it, there are 124 different things to test for. And this is what they consider, you need to test for when you're testing a web application. And what's nice is it says, hey, what are you doing? Well, we always start with information gathering. So we're going to conduct search engine discovery, right? Going way back to what we were doing with information gathering in the beginning of the series. That makes sense. And it says, hey, Google hacking, you can use tools like SiteDigger, Shodan, etc. And then you have a checklist here. You could say, yeah, I did this, it has no issues, or it has issues, or not applicable, and it tells you a description. That's great. Part 2 of this, that's actually fantastic too, is if you come over and you go to Google one more time and you say OWASP checklist PDF, the first thing that comes up is this OWASP testing guide. And I'll provide links to both of these in the description or the references section. But if you click on this and you see here OWASP testing guide 4.0, now you can scroll through this and it might take just a little bit. I'm going to try to cheat a little bit and scroll down. And what happens is eventually you're going to run into the same checklist area. So you're going to run into info-001. I believe it starts at 3, chapter 3 here. So it covers the framework, or actually chapter 4, I apologize. And you come through here and you have OTG-001. And this is on page 30. So OTG-001, if we go back to our Excel, you can see OTG-001, okay? And what's nice about the PDF is it says, hey, here's what you're looking for, here's the test objectives, here's how you test it, and it gives you all different tools, examples, etc., what you can be looking for in here. And then it goes into 002 and goes right through it. When I first started out pen testing against web apps, and still to this day, I use it a little bit less, but I still use it. I use this PDF like, I went literally line by line on this. I used the PDF and I tested for every single thing in here, so I left no stone unturned. And that's kind of the story time I want to get into real quick on why having a checklist is important, and then we'll wrap up the video. So this checklist, one time I was sitting with a very much senior web app tester, a brilliant guy. I would trust him to test a web app. And what had happened is we had been testing this website this whole time, and we weren't really finding anything, but we weren't using a checklist. We were just kind of going off methodology from his head and, just testing the application as he saw it. And he was like, the last thing I do in an assessment is I go back and I go through the checklist and I check the boxes and I say, yes, I did this. No, I didn't. And well, we were scrolling through the list, and then there came up something about, checking on the account creation parameters or sign-in parameters. And there was something, I'm just going to use this to type in here. There was something when you were creating an account that said admin equals false. So what if you were intercept your request and change it to admin equals true? Well, guess what? It made the account an admin when you registered. Now, had he not checked the checklist, he would have just let this mentally lapse. It didn't mean that he didn't know how to test for this or what he was looking for. It just means that the testing here is overwhelming. Again, there's 120 something of these to look for. You're bound to forget about one or two. It's just human nature. Most people are not going to be capable of memorizing this. So please utilize a checklist in your testing. It's so useful. You have all these resources available to you, and you should take advantage of them fully. So that's my spiel on this. Again, I use this. I give this to a client every time. I have my notes in here, and I'll make the notation. That way, when we go back, we can reference anything or any questions they might have when it comes down to what I looked at and what I saw and what I didn't see. So from here, we're going to go ahead and do some installs to get our setup ready. And we're going to start talking about Burp Suite more in depth after that and start working through the OWASP top 10. So let's go ahead and move on to the next video. All right, so now we're going to work on installing OWASP Juice Shop. So to be able to do that, we're going to have to do a few installs prior to, and one of those is going to be Docker. So we're going to install Docker, and it's a little bit complex when it comes to Kali Linux, at least what we have to type into the terminal. So let's go ahead and open up a terminal, and let's open up Firefox. And I'm going to take you to a website where we can just kind of copy paste things, and I think it's really great. So if we just go to Google and we say install Docker Kali, something like that, the first one that should come up is installing Docker in Kali Linux updated for 2019.4. Go ahead and click on that. I will also be adding this to the references down below. So what we're going to do is we're just going to scroll down a little bit and we're going to go into the preparation section here. So now it's saying that we have to ensure that Kali is fully up to date. We don't have to do that here. It's going to be okay. So let's just go ahead and grab this and we'll copy and paste. Okay, you should get the okay back. Now go ahead and just copy the next line and paste. All right, now we just need to run apt update. Okay, so just type in apt update. And that will update this. And now we are updated. So now what we need to do is just run apt install docker-ce. So apt install docker-ce. And this is going to be 385 megabytes. So go ahead and hit yes on this. Accept that, and it's going to take a little bit to install, okay? So what we're going to do is we're going to talk about OWASP Juice Shop while this is installing. So let's go ahead and go out to Google and open up OWASP Juice Shop and kind of get an understanding for what it is. So with Google there, let's go ahead and just type OWASP Juice Shop. And there's two pages I'm going to want you to open. The first page is this GitHub page here. So go ahead and right click, open a new tab. And then let's also open up this getbooks.io page. And I'll provide references to these as well if you need them. So what we're going to do is if we scroll down just a bit, we're going to be following the Docker instructions on the install down here. So you can see Docker container, we got to install Docker, and then we're going to run these specific commands here. Before we do that, what is Juice Shop? Well, Juice Shop is made by OWASP, and it is a vulnerable website. They have a fake Juice Shop online, and we're just going to go out and we're going to attack it. And we're going to utilize our attacks to learn a bunch of the different OWASP top 10s. And there are a couple of different ways to deploy this. We could actually really easily deploy on Heroku, which would bring it out and you can attack this via the World Wide Web. And this would not be local to your machine. Anybody could attack it. It's not a big deal. It's not, it's made to be vulnerable. There's nothing out there that would leak information about you. However, there's a couple attacks that cannot be performed on this, so that's why I'm going the Docker route. You could just as easily go this route if you want to and just watch and learn on two of the attacks. Otherwise, let's go ahead and do the Docker installation. So let's finish this out and let's talk about the Git book as well. So on the Docker, all you got to do is just Docker pull here. So go ahead and copy this and paste. And that's going to pull down Juice Shop, which may take a minute or two depending on your internet speed. And mine's done. So if you need to pause, feel free to pause as always. And then we're just going to run this Docker here, and this should boot up Juice Shop. Let's go ahead and run that. And port 3000, server is listening on port 3000. Perfect, that's what we want. Go ahead and open up localhost 3000 here in a new tab. And boom, we have it working. So this is the Juice Shop. Congratulations, your application's running. So here, go ahead and just dismiss this. And you can see we have a website, and we're going to pen test against this website. Before we do that, and before we start getting into this, the Git book is the fantastic resource of the course. Let me see if I can make this a little bit bigger. So the Git book has not only just an overview of what's here, it has all the challenges here. So what we're going to be after and what we're going to find here shortly into the course is that we're actually going to have a scoreboard full of challenges. And these challenges range from 1-star challenges all the way to like 7 stars. So a 1-star challenge is pretty easy. 7 stars like really, really hard to do. I'm going to cover these in the best way that I think possible. We're not going to cover every single one of these. We're going to cover what's applicable to learning the OWASP top 10. My thoughts for you are that you should still come through here and challenge yourself to work through some of these challenges. So while we only will cover the top 10 and we can learn about those, if there's a topic in here that you want to learn about, it's really great. Like say XXE, XML external entities here. We click on it, it tells you what XXEs are, And then it says, hey, we've got 2 challenges related to this, and here's the difficulty for them. So you can go and look up these challenges and try to solve them. And if you can't solve them or you can't figure out where it is, well, guess what? You can go to the challenge solutions down here, and you can scroll down. You can look for it under the 3-star challenges, for example, or you could just do a Control F and find the XXE challenge and solve it that way as well. So it's got the challenges, the solutions, and all the different ways to click on this and sort. And when we get to the scoreboard in the app, I'll show you how to sort through that as well. So you should have your app up and running, and we should start being ready to be able to attack this. So in the next couple of videos, we're just going to focus on installing a couple more things and exploring Burp Suite and kind of starting to scan our website with Burp Suite, and just as a precursor to getting in and learning some of these attacks. So that's it for this lesson. I'll go ahead and catch you in the next video where we install Foxy Proxy, which we'll need for Burp Suite. So now with our Juice Shop up, I want to go ahead and open up Burp Suite. So go over here and open up Burp Suite. And what we're going to be doing is we're going to be setting up a tool called Foxy Proxy. And Foxy Proxy is going to allow us to easily switch in between proxies. And I'll show you exactly what that does. So remember from way earlier, we set up our proxy. We had to go into here, go into preferences, scroll all the way down, go to the network proxy, click on manual configuration, hit OK, and then the proxy worked. That's a lot of work, especially when you want to, close Burp Suite and then you have to go back and you have to do this over again just to get out of the proxy settings. So let's go to Google and let's just type in Foxy Proxy. And we'll download it. It's right here. Foxy Proxy Standard. Get this extension for Firefox. So go ahead, click on that. And then once it pops up, we're going to go ahead and download it. So add to Firefox here. Should just take a second to add. And then it's already added. So just like that. Right here up in the corner, you should see the little fox with the red circle through it, or red line through it. We're going to go ahead and go to Options when we click on that. We're going to hit the Add button over here on the left side. And we can title this Burp if you want. And then I just give this HTTP is fine. And then we can just say 127.0.0.1 port 8080. And then we'll go ahead and just save this. And now we can turn this on by just clicking on this, clicking on Burp. And then our proxy should be intercepting. Now all we have to do is refresh Juice Shop, and now we've intercepted the proxy here, and we've got everything ready to go. So in the next video, we're going to explore Burp Suite and take it further from where we went in the beginning of this series and really get into the weeds with Burp Suite and understand what it's fully capable of, and then we'll start exploring different sorts of attacks. So I'll catch you over in the next video. Now let's talk about Burp Suite. Since we have everything set up, we've already installed Burp Suite in an earlier video, and we got the certificate set up. We talked about what it's capable of, and we did a basic intercept and kind of just looked at the responses that we were getting, and we saw that we could do a little bit of enumeration through it. But for this entirety, pretty much of all of these exploits, we're going to be using Burp Suite in one way or another, and it's going to be really flexible, and you're going to see what it's capable of doing. Now, I am going to be using the Community Edition. I will describe the differences as we talk about it of the Pro versus the Community. And in this video, I just want to give you a high-level overview of what we're going to be doing. And I also want to talk briefly about what to expect when you're doing a web app pen test. So typically with web apps, you have 3 stages of testing. You have a unauthenticated stage. So when you come in here and you are on this website, like you're here, right? And you go to account, there's no account. We're not logged in. We're considered unauthenticated. So with that, we can try to navigate around the page. I'm going to turn the intercept off here, and we could just click around and see what we can find, right? Click on certain things, see what's available to us, see what we're capable of as a user. We can go to login form. We could try to log in here with, credential stuffing, or we could just try admin if we see default credential kind of deal. We can go to forgot your password and try to utilize if you forgot your password scenario, and etc. Okay, so there's a lot of different features that we can do. The second tier is what's called a user tier. So we log in as a user, and we don't have admin privileges, but we do have some user accessibility. So we'll get some sort of extra access that we wouldn't have as an unauthenticated side. And then lastly, we're going to test the application as a admin user. And that will give us access to admin panels and other things that users should not be able to see. Well, we do all this testing to see if maybe from the unauthenticated side, you can access an admin panel, or maybe from a user side, you can access an admin panel, or you can just bypass certain restrictions that should be there across these users. So it's always good to test and see who can get to where and why. And we want to find all those vulnerability types. So when we're doing this testing, we come in and we start unauthenticated usually. And what I like to do is, again, I just like to click around and kind of get a feel for what's going on. So, there's customer feedback, there's the about us here. I'm just clicking through photo wall. And if you go to target, we have our local host of 3000 here. I always like to just get the target and I like to just add it to the scope. So I'll right click and add to scope. And then I'm going to go ahead and just click up here on the top, and I'm going to say show only in scope items. So that filters out the rest. That way, when the proxy's picking things up, it's only picking up and storing in this area what we need. So if we clicked on this here, you can see that it's starting to pick up things that even we didn't go to. There's API back here, and you can see challenges, feedbacks, quantities. There's a lot of different things in here that we have access. Look, there's a REST admin, and we can kind of click through some of this stuff and see if any of this is interesting. And this is what we want to do on unauthenticated side. And what this is doing here is this is going through and it is pulling down information from the traffic that it sees through this proxy. And one feature that we do not have access to is the scan feature. Now, Pro Edition has access feature of scanning and of engagement tools. So we're going to be without those for this course. But if I were doing a pen test, I would have Pro, and you will have Pro as well. And you're going to want to scan the site, and scanning will do two different things. One is going to do crawling. And these used to be called spidering, and this was a feature that was part of Burp Suite prior to edition 2.0. So they took that away and made it more of a paid edition type deal. But you would do spidering, which is trying to go out to different websites within the branch here, and it's going to look for other sites and try to see where it can get access to. On top of that, we have what's called active scanning. Now, active scanning will go out, and we have a dashboard here, and this is just a demo, but it shows the different issues that it might pull up, and it's going to actively scan against a website, and it's going to try to do SQL injection or do cross-site scripting attacks or do all these different attacks and see what it can pick up. Now, the thing about scanning, and with my experience, and I've ran actually Juice Shop through a scanner before, it picks up maybe 10% of what's out there. So scanning is nice, but you shouldn't rely on your scanning. You should rely on manual testing and going through your checklist. Scanning is good at picking up some things and helping you identify certain little flaws here and there, but do not rely on your scanners. Don't rely on your Nessus. Don't rely on your Burp Suite Pro or any of that. While they're good to have, they're not fully reliable. So let's talk about some of the features of Burp Suite and what we can do with it. So you've already seen the proxy feature. We can turn the intercept on, and when the intercept is on, we refresh a page here. You can see that it intercepts, and it just hangs this page. And what that's doing is this is giving us the option to mess with this, or at least see what's going on here. We can see what the request looks like. We're making a GET request, and we're making it to the local host, and we have our user agent here. We've got some cookies, and this is just a basic request. Now I want you to right click on this request and go ahead and just send that to repeater. And repeater is a request repeater. So we can go ahead and send this request, and you can see what comes back. Okay, we get a 304 not modified. So let's go here and just forward this request and see what happens. And you can see get socket.io comes through, and there's a few little things that's going on. This v1's coming through, which is telling me that this is an API, and we're going to keep forwarding through. And what's happening too is we're intercepting more than just localhost 3000. So what we want to do too is we're going to go ahead and go into the options here, and we're going to say we're going to intercept client requests if target's in scope, and server responses if the target's in scope. That way we don't intercept anything from any other websites. Mozilla will go in the background and have requests come through while you're sitting there on intercept as well. So a repeater allows you to repeat requests. When we're doing this, what we can do is say like we want to do parameter tampering, or we wanted to test here. We say, you know, we got to get requests. Let's go ahead and just change it to a post request, and let's see how the website handles it. And we can make different modifications. Maybe we delete a cookie here, or we change the user agent, or we do something in here that is a little bit malicious after we've intercepted this request, and then we take it to repeater, and we can repeat our request over and over and over. And you'll see how this becomes useful as we go on through the course. So other things, we've already covered intruder in this course. Now, intruder again is where we can store a payload, and then we can use that to use an intruder attack. Now, the intruder attack on Community Edition is very slow. We don't have access to a lot of speed here because they limit you, because they want you to buy the Pro Edition. You can go into the extender store here, and if you go to the App Store, if you click on App Store, sort by popularity, and there are some free ones. So you see the ones where it says requires Burp Suite? There are some free ones in here that we can install, and one of those is actually the Turbo Intruder, which would do intruder at a faster speed. We're really not going to need it for this course, but I just wanted to point out, and this is another feature too of Burp Suite versus Pro, is that the Pro Edition has all these additional scanning features, like Active Scan++ is additional on top of the active scanning that it does. It looks for even more vulnerabilities. Retire.js looks for vulnerabilities in JavaScript libraries, which is really nice. You know, and you go down the list and there's all these different really, really nice features, like CSRF looks for CSRF vulnerabilities. And you don't have to know what any of these are right now, but it's just nice to have those in the Pro Edition that we won't have now in the Community Edition. So on top of this, we have a comparer feature in here. We can send one item to compare and then another item, and just to look at the differences if we want to. I don't use this too much, but it's always nice to see if, hey, has something changed on this page and what changed in the page or the response that we got. Decoder is a nice feature as well. So say that you have something like, I can highlight this cookie and we can just send this to decoder. And say something is encoded as like base64 URL encoding. You can go ahead and decode this, or you can encode this. So say you want to encode this whole thing as URL encoding. Well, it encodes the whole thing. Or you want to encode the whole thing as, base64. Well, it'll put this into base64. And this is just another feature of Burp Suite that is good to use. Mainly what we're going to be using in this course is the proxy intercept. We'll be hanging out a lot in the target page, and we'll be looking through the targets and what comes through when we're scanning. And we're going to be in the repeater tab mostly. So the repeater is going to allow us to intercept requests, send them to repeater, and modify the requests, and keep targeting different things until we get something that works for us. So that's just a high-level overview. Again, it's not going to go into full detail because we only have the Community Edition. I do recommend purchasing the Pro Edition once you get into it. So it's not a necessity right now, but if you are interested in like bug bounty hunting, or if you want to get the full effect of learning web apps, I highly recommend the Pro Edition. But again, it's not a necessity at this time. So from here, we're going to move into our different attacks, and we're going to start explaining these attacks, and we'll focus on each one of them and what we can do with them. So the first attack up in the OWASP top 10 are injection attacks. So in the next video, we're going to start talking about SQL injection. So before we get started with our injection attacks, I wanted to quickly show you the scoreboard. So go ahead and navigate up to your local host. Make sure you have a # /score dashboard, and you should get an achievement here for finding the hidden scoreboard. So in this scoreboard area, you should have access to all the different types of vulnerabilities and all the different types of ratings. So let's go ahead and I can show you all these. And if we hit show all, and mine's lagging just a little bit, but this organizes it by alphabetical order. So this is all the different challenges that you can come through and attempt. Now, if there is a little university type hat over here, it's a walkthrough. It shows you an interactive tutorial by clicking on the orange button here. And there's also ways to click on these and get hints as well. So you can do interactive challenges and you can come in here and get hints if you're able to, or you're having issues finding some of these things. So what we can do is, for example, with injection coming up, we can say, hey, let's go ahead and hide all these and just sort by injection. And we could see, okay, there's a bunch of different injections in here. Now, we're not going to cover all these injections. We're going to cover the basics of SQL injection. So, for example, if we want to start with the basics, we're probably going to want to start with the least difficult. So the 2-star here is the least difficult. And guess what? Actually, it's a walkthrough for us too. But we can go in and it says log in with the administrator's account. Okay, well, we got to figure out how to do that, right? But there's hints in here if we want to click on a hint and try to get hints, or we could refer to the challenge solutions as well. But this is what's nice. It brings you right to injection. It tells you about injection, what it is, right? You come up here, it says, here's what injection is. And then it brings you down specifically to this one and kind of gives you hints on what you might need to do here in order to log in with the administrator's account. So with that being said, the scoreboard is your best friend. We're going to be covering a topic or two from each section from the scoreboard. We'll talk about an overview, we'll do a walkthrough, and then we'll talk about defenses, similar to what we did with the Active Directory portion. And this will just get you familiar. That's all we are doing here. Remember, this is not a full-on web app course. This is more of familiarity. That way you have something to bring to an interview and something to build upon. So let's go ahead and move right into injections, and we'll start focusing on this one right here, the login admin, and we'll talk about SQL injection attacks. SQL injection attacks. So what is SQL injection? Well, SQL injection is where we inject malicious SQL statements into a SQL database. These are super easy to avoid, but it still happens very often, and it happens due to poor code. We'll talk about that in the defense section. But if we're successful with a SQL injection attack, we're capable of reading databases, extracting information, modifying databases, and potentially we can even get a shell with this. So from here, let's go ahead and talk about some common SQL verbs. These are things you're going to be seeing and you should know. So feel free to take notes on this, or just watch the first time through and then take notes the second time through. But these are common SQL verbs, and let's just cover these really quick. So every SQL statement begins with a verb. And for example, one you're going to see a lot of is select, and that's going to retrieve data from a table. Insert is going to add data to a table. Delete's going to remove data from a table. Update's going to modify a table. Drop is going to delete a table, very malicious. And union is going to combine data from multiple queries. And I'm going to give you examples of all these statements here in just a second. So there's some other common terms that we should know as well. So we could say where, and that's going to filter records based on specific conditions. You're going to see an example of this. There's and or not, which is going to filter based on multiple conditions. So we have one condition and another condition, or another condition, or not a condition. Similar to when we were talking about Python earlier, same logic. And then we have an order by as well. So this is going to sort records in ascending or descending order. Now there's a lot more terms than this, but these are the very, very common ones and ones you should know. So let's look at an example let's say here that we have a SQL table, and the table is called users. And we have 5 users in this table. Now we've got Frank and the username here, Frank, full name, Frank Castle, email, punisher@marvel.com, and the country they belong to. So what's going to happen when we say select from, and then we say users? Okay, well, we're going to select star from users. So star is a wildcard. And this here is an end statement when we have the semicolon. That's ending the statement. So we're just going to say select wildcard from users, meaning select everything from users. So if we select everything from users here, we're going to select this entire table. If we want to select user ID and username from users, well, guess what? We're going to just pull down this column and this column. So we'll pull down user ID and username, and we won't pull down any information from here. If we wanted to select every single thing from the users table where a condition applies, say country equals Russia, well, then we're only going to pull out Natasha here, the Black Widow. Or let's try one more. If we select everything from users where the country is the US and username equals Frank, well, the US will pull down all of these, right, except Natasha. And then we also set the condition of Frank, so it's only going to pull down this first column here. So with that all being said, let's quickly talk about special characters you're going to see in SQL. So you saw an example of a few here. We had string delimiters. Again, we have a single quote or double quote, right? And what that does is that's just for a string, similar to coding. And a lot of this logic is like programming logic. We have comment delimiters. So we have a dash dash, which you're going to see here very soon. We have a / asterisk, and we have the pound sign. So again, feels like coding, right? And this is just another type of language. So we have wildcards. You saw the asterisk. We also can use the % symbol for a wildcard. We have the end of a SQL statement, which is a semicolon, as you saw in the last slide. And then we have a bunch of programming logic. So we have equal signs, plus signs, greater than, less than, parentheses, and you can put things into programmatic logic. So that's it here. What we're going to do next is we're going to dive in the application and make a lot more sense of this and what's going on. We'll talk about how to test for this and some different options that we can do. So let's look at SQL injection and talk about the different types of SQL injection and see what we have available to us. All right, now we're here. We're going to do our first web app attack of SQL injection. Now we have the account login page. Make sure you navigate to that. And that's kind of where the hint came from on the scoreboard. It said, hey, we're going to utilize the login feature to kind of attack SQL. So I kind of want to go over this and talk about what we're expecting here. So let's say that we log in. Let's turn an intercept on. And let's say that we log in and we say test, right? And we log in, we'll intercept that request. And we can forward this one. We're looking for the username, password. Here we go. So we got email, password here. And let's go ahead and just right click and send that to repeater. And if we try to log in, it says invalid email or password. Okay, that's fine. What happens though if we try to throw something in here malicious? And let's back up just a second. I want to cover what's going on behind the scenes. So what's going on? Let's open up a notepad. Okay, so we have this input, right? We're putting in the email field, we're putting an input of test. And what's happening behind the scenes, say we have a SQL injection, all right? The SQL injection is trying to grab that. It might be grabbing something along the lines of select star from users where email equals test, okay? So what it's doing is it's saying, hey, I want to select everything from users where the email is equal to this test, what we just input into here. Now, if we have SQL injection, let's copy this. I'm just going to paste it. Let's say instead we put, a single quote in here. Well, that single quote's going to come in and it's going to add into there, right? So we're saying, hey, from test here. And guess what? This completes the statement. And now this little other single quote that's left over is going to throw an error because there's no end to the second quote, right? So this isn't logically correct. And because of that, we could cause injection. If this is allowing us to inject this single quote here, then we might run into issues. So let's take a look at repeater. Let's say we put in the email here, we put a single quote and we send it. Oh, look what happened. So we got a 500 internal server error. And from that, we have got a SQLite error. Oh, this is so good. What is this telling us? Well, this is telling us, one, this is a SQLite database, so that gives us some information. And if we come through here, we're seeing that there's a database error. And when we get an error like this means we have some sort of injection. Okay, this is a big sign that injection exists. And something I actually have never really seen before, when you come down here, it tells you the SQL of what's happening. So the SQL of what's happening here is it's saying, hey, select star from users where email equals test. So we guessed that right, actually. And again, there's an and condition here. Password is equal to, and it looks like it's just hashing that password of test. And then it's putting in here, and delete at is null. So if the account was deleted, if it's null, then it wasn't deleted, right? So it's saying, hey, this account still exists. It matches this password, and it matches this email address. Perfect. So how can we improve upon this? Well, let's take a look back at our notes here. So we got the notepad. Let's make one more of these. So what if I made a situation like this? I said test or 1 equals 1 dash dash. And what's that going to do? That's going to come into here, and that's going to say or 1 equals 1 and the statement dash dash. Okay, so what is this doing? Well, first let's focus on this part right here. We're closing out this email. It says test, and then we close it out, right? Then we're adding a condition. We're going to say or. So this email doesn't exist, right? Because it could exist, but it's going to say, hey, where it matches this, or this is true. Well, guess what? 1 is equal to 1. So this is true, making this entire statement true. We add a ending here, okay? We add our ender, and then we put in a comment. Now, what happens with a comment? Everything after that comment no longer exists. So if we put that into here and we put the comment in, guess what? We don't have to check for a password. We don't have to check for and deleted is null. It doesn't care. What's going to happen here is it's going to allow us to log in with this statement. And it's going to allow us to log in as the admin user. Why is that? Well, if you recall the users we had like IDs of 1, 2, 3, 4, 5. We had Frank Castle at the top. Typically, ID number 1 is your admin user. Okay, so if we are going to log in as the first user in the database. This is going to pull back the first user. Typically, it's your admin user. So we're going to utilize common SQL injection here. We can copy this entire statement if we want and just paste this in. You can put anything you want in the password and then attempt to log in. I'm going to undo the proxy here. And that actually solved the challenge for us. We wanted to generate an error. And I could show you that really quick. If we try to log in with this, you get an object error, which is another indicator that something's going on this side. But this is why, look at what this shows you compared to what repeater shows you. Repeater shows you a lot more information. So I always like to run my testing through repeater. So let's go ahead then and try this and log in with it. And guess what? We are logged in. Successfully log into the admin account. All right. So here, let's talk about some more things. We've completed the challenge, and that's great. But let's also focus on what we're seeing here. What we're seeing here is SQL injection, and this is classic SQL injection. Now, there's a possibility that we have SQL injection and we aren't able to see it at all. And that is called blind SQL injection. That becomes a little bit more complex. And to talk about this, because it may show up in an interview, blind SQL injection, if you're trying to test for it, you might have something like this. And let's go ahead and pull up our little notepad again. So you might have a command in here where you say, we'll just make up a fake injection. Don't worry how it plays into the SQL statement. But you might say something like sleep 5, right? And it depends on the SQL database you're using. So the sleep term changes and how you enter it. So I'm just making this up right here. But you're going to say, hey, sleep 5. And what's going to happen is the website is not going to respond to you for 5 seconds. And then you're going to say, hey, sleep 10. And then the website's not going to respond to you for 10 seconds. Well, that's how you can determine that, even though you can't see an error code like this, like when we see this error code, we know we have SQL injection. This is bad. Okay, it's only a matter of time to figure out how the SQL injection works. And then we can kind of go from there and pull it off. But when we inject this and nothing comes back, it just comes back as like a normal login screen and we just have no idea. Well, then we could start throwing in like these sleep patterns and these testing to go with it and seeing if the page responds back or doesn't respond back. And Burp Active Scanner is actually really good at doing that and at least trying to pick up on these. It'll send sleep commands and see what the responses are and kind of help try to identify some of that. So that is it for this video. My challenge to you is to go into your injection here. Remember, injection, look at the different challenges that are available to you and play around with them. Make Juice Shop your friend and understand these. If you go through all of these challenges, you don't have to know how to solve them. That's not necessarily the point here. The point is to go through the challenges and even work through them in order of difficulty. So you just did a 2-star challenge. Maybe go look at the 3-star challenges and see how you can take those. The Christmas special is actually a really good one. And you can keep going through this and you can learn a lot about different injection here. And again, you don't have to know how to do this. Go to the challenge solutions, read the challenge solution and follow it along. Take notes, understand what's going on and why it's going on. So now you know what SQL injection is. You understand that, hey, we're getting injection here, and we're putting it into a statement and we're modifying that statement to make something happen in our favor. That's all it is. We can get very malicious with this very quick. So from here, we're going to go ahead and talk about how to defend against SQL injection. So I will see you over in the next video. Let's briefly talk about SQL injection defenses. Now there are more than 2 defenses out here, but these are the 2 big ones. And really the biggest one is parameterized statements or parameterized queries. And what that means is it ensures the inputs, or also known as parameters, are used safely in SQL statements. So they're passed through the SQL statement safely. An example here I have are a good example and a bad example. So here's a good example. We've got select wildcard from users where email equals ? Okay, and what does that mean? Well, the way we're passing data here is the parameterized string is going to be passed separately than the parameters being provided. Okay, in this statement here where we say select wildcard from users where email equals, and then we just provide the email as like a variable, it's going to take the entire SQL statement and it's going to provide it all at once. So this parameterized statements is really the way to go. And this is just responsible coding. Okay. And this is when I said in the first video that SQL statements or SQL injection attacks are easy to prevent. They are. I mean, look at the difference in the code here, but you still get coding that comes out like this and allows for SQL injection attacks. The other idea behind this is to sanitize input. Remember when we had the single quote and we had the 1 equals 1 type statement? And that should never happen, right? So if we have that kind of statement, that should be sanitized. And you could sanitize all the way down to very specifics, like you should not have the like a single quote in there, or you can specify entire statements like the single quote or 1 equals 1 dash dash. For an example, you could take that entire statement and say, hey, that's suspicious. I'm going to sanitize that. So ensuring that the input that is provided is not malicious is important as well, but we can prevent it here entirely with parameterized statements by ensuring that the parameters are sent separately, right? So that's really the big takeaway here. If you're asked on an interview how you can do this, parameterized statements should be your first answer. You can also talk about sanitizing input. That would go over well as well, but we're after number one here when we're interviewing. So that's it for here. We're gonna go ahead and move on to the next attack, and I will see you over in the next video. Let's talk about broken authentication, which is second in the list for the OWASP top 10. Now, if you want to go to this page, I will link it down in the references, or you could just go to Google and say OWASP broken authentication, and it should be the first one that pops up. So when we talk about broken authentication, there's a lot of different attacks here. And if we look at is the application vulnerable, I kind of just want to talk through this, and some of these are going to be very familiar to you. So when we talk about authentication, we're talking about how can we get access to this application, right? And how can we authenticate to the device? Now, there's a bunch of different options here. If we go down the list, now it says, does it permit attacks such as credential stuffing? So can we just supply a valid list of usernames and passwords and gain access? You've seen that in the past. And when you're talking against a web application, that's considered broken authentication. Does it allow brute force attacks? So there should be some sort of rate limiting that's happening. If we are giving a brute force attack to a website, if we're conducting a brute force attack and we are able to submit hundreds upon hundreds upon hundreds of requests, then that's an issue, right? And that is going to cause a situation where we are able to log in with an account given enough time. Another thing is it says, does it permit default weak or well-known passwords? Well, admin is such a real thing. If you encounter a website and you find a login portal, you should be looking for something like admin, or you should be looking for default credentials if it's something that is a well-known service. Something like, for example, Apache Tomcat, which you saw in an earlier video where we logged in with default credentials. In the next video, we're going to talk about the next one, which is using weak or ineffective credential recovery or forgot password processes. And this is where if you have the forgot password process, you go there and maybe something like on the screen is the question for the user or the question that they're going to ask. And we see this a lot, and it's just bad practice because that might be guessable. Like, what street did you grow up on? Well, you know, there's only so many streets that we can pick out there. Or if we do a little bit of research on this person, guess what? We can probably figure out where they grew up, what street they grew up on, and narrow it down. So, you know, this is just repetition here on a lot of this stuff. Skipping down a bit, does the website have multi-factor authentication? Meaning, if we do credential stuffing and we do log in as the user, is it going to block us once we log in with multi-factor and say, hey, we need something else from you? Or is it just going to let us in? And other things it's asking about, does it expose session IDs in the URL? So sometimes your session ID or your cookie is going to be in your URL, which is not good. It's not best practice. And will it rotate your session ID? So what happens is when you log in, you should get a session ID and it should rotate. Some websites, when you go to the website, it gives you a session ID and then you log in and then it rotates, you log out and it rotates. Some other websites, you log in and the session ID stays the same, and you log out and the session ID stays the same. That is what's called session fixation, and that could get really dangerous as well. And so just looking over these, it's all dealing with authentication issues, and it's a big bucket of things that it could fall into. And for this one, we're not going to talk prevention in a separate video. We're just going to talk prevention kind of as we go and through this. But, you know, you should be checking your website. You should have multi-factor authentication, right? You shouldn't be using weak credentials. You should be rotating your session IDs. A lot of this is kind of like common sense, but it's overthought or overlooked, I should say, when developing applications. So these are just easy wins for us. You should have a rate limiting when you're doing brute force attacks, or you should have like a CAPTCHA on there or something that will prevent me from attacking your website or your login over and over and over. You should not be allowing weak credentials. You should be doing checks for those. You should have, just preventative measures in place for all of these sorts of attacks. And for reference, this is great down here. Again, the cheat sheets on different things and different types of attacks in here. Session fixation, you can see is actually in my history because I navigate to this quite a bit. This is one that we find quite a lot, and we'll cover this when we get to the reporting section. So keep that in mind. Again, I'll have a great example of session fixation for you in the reporting section. So from here, we're going to go into a how-to video when we're just going to talk about testing for it and looking for broken authentication. And I'm going to talk about some minor findings that we might encounter as well, and how we're going to look for those, and just how we would test for this more so than how or the vulnerabilities that are there. And I'll explain that in the next video why we're doing that. So I'll catch you over in the next video when we start testing for broken authentication. So here we are on our application. We still have Burp Suite up. This should just be a continuance for you every video. So I'm here, I'm gonna go to account, and I'm actually going to log out of this account. And from here, I'm gonna go back to account into the login page. So we're gonna play as if we were unauthenticated for right now. So what do we wanna do? First thing, when I see a login page, I wanna check actually for any kind of enumeration that we can do, username enumeration. So we could do test@test.com and just do test here, and just submit this and try to log in. And this is great. This is what you want to see. You don't see this all the time, but this is what you want to see. So it says invalid email or password. A lot of places will just say invalid email address or incorrect password. That way you know, okay, well, the email address is correct. I don't know the password. If that were the situation, that would be a finding. It would be a low-level finding, but it's still considered information disclosure when you are allowing for username enumeration. So keep that in mind when you're at a login page like this, something that you want to check. Now, from here, we can go to, hey, I forgot my password. And in here, we can do the same thing, test@test.com. And remember, we were talking about the username enumeration before, and well, guess what's happening? We don't have a security question coming through here, right? So that's an issue. This is username enumeration. For example, we did log in as the admin user, and their email was admin@juice-sh.op. And look, now we are able to click on this. This is bad. This is so bad. There are situations I see, especially doing web apps all the time and bug bounty hunting all the time, where you have the situation where if you provide an invalid email address, nothing happens. Or you say, even if it's just, imagine there's nothing right here down. It just says, hey, I forgot my password. I don't know. I'm going to go ahead and just say, here's my email address and submit. And it'll say, we don't have that email on file. Well, then that's still username enumeration, right? So here, this is also username enumeration because we weren't able to get to this security question until we provided a valid username. This is not good. Now, we take this and it tells us, hey, what was your mother's maiden name? This is bad. This is very bad because it's allowing us to just go do OSINT or go do Googling and say, hey, I know who this user is. Let me look up what their mother's maiden name might have been. And it's very possible that it's just this person's last name. And then we come in here, we reset their password, and we're good to go. And we change this, right? So this is a very, very bad example of a good example of a bad login form. Other things we can check for is session fixation. So we can create an account really quick, and I'll show you what this looks like. So if we go to log in and we go not yet a customer, and we'll just make a test at test.com really quick. And I'll make the password test1234 and test1234 as well. And we'll just do a security question of what's your eldest sibling's middle name? We'll say Bob. We'll register here. Okay, so now we're registered. Let's go ahead and intercept this. And we could see that we have these cookies here, continue code, whatever. A lot of times there's a session ID specifically. Let's go ahead and just send this to repeater so we have this saved. And then I'm going to turn this off. Let's go ahead and log in now as test at test.com. Test1234, log in. Okay, now let's turn this back on and refresh and see what we got. Okay, now we have a token. So this is okay. We have this token here. This is good. So we could test here for this session, and we can see, okay, well, the session didn't need to rotate because there was no cookie here to start or a session token to start. So that's good. This is no session fixation here. We're testing okay. We could also, log out and see what happens. We can send this to repeater as well. And so we have repeater. We get a request here. Well, it says 304 not modified. That's fine. What we're after here is we're just trying to see if when we actually log out of this now, say we log out, and then we refresh this page, if there's any cookie or token or anything in here, and there's not. So that's a good sign as well. We could try as well to come into this repeater and pass along this session and see if we can get in with this session token, if it actually expired anything, or if this changes when we log in to something different. And there's a lot of things that we can do playing around with these session tokens. But what we're after when it comes to this testing for broken authentication is there session fixation here? And I'm not seeing it. But it's good to look around at all these features. And again, like the username enumeration doesn't happen at the login page. And even if it doesn't, it happens a lot on the forgot password page. And if we're able to brute force this page repeatedly, that's an issue. If we're able to, use default credentials here, that's an issue. If we're able to log in and there's no multi-factor authentication, which there isn't, that's an issue. So these are things you're going to start looking for and thinking about and prodding. So not only are you checking, SQL injection here, which we do on login forms and pages, but we're also going to be checking for authentication issues before we ever log in as well. Can we bypass authentication? So that's it for this lesson. Hopefully this all makes sense. Again, I do encourage you to, for every challenge, to check out all the challenges here. And the reason we didn't actually do any of these solutions, if we go into broken authentication, most of them are relating to the reset feature. You could see change feature, or change password here in the reset. So for me, it didn't feel like it was really a challenge. It was more of like going out to Google and figuring out the answer, like to a Bender, for example, is from the TV show Futurama, and it wanted you to figure out his security answer, just proving a concept. So I just wanted to talk more theoretically through this instead. And again, like I was saying, go out to the OWASP Top 10, review a lot of this stuff. You can go into these challenges and give it a try on your own just to kind of understand what they're wanting from these aspects and why broken authentication is bad. And it's number 2 because it happens so much. So from here, we're going to move on to number 3, which is sensitive data exposure. So I'll catch you over in the next video. So number 3 on the list is sensitive data exposure. And similar to number 2, I kind of want to just talk about it theoretically from a attack and defense perspective, and then we'll dive into Burp Suite and we'll talk about how we might hunt for these things and what are some common scenarios. So sensitive data exposure is exactly what it sounds like. Imagine that you're testing against a hospital and the hospital is exposing PII or personally identifiable information, or like a social security number or a date of birth, patient information, whatever. Or you're testing against a client and they're exposing credit card or financial information that violates, PCI data. Those are very bad situations. There can be situations where, you have passwords stored in a clear text file. I've had situations in the past, and I can tell you two of them. So one situation is that recently I was testing against a bug bounty program, and that bug bounty program was a government program. It's public, so it's okay to talk about this, but the program had a JavaScript file that was wide open, right? And this JavaScript file, if you read into it, guess what? There were stored credentials in there to access their website. And I love testing against government because the government just kind of has weak protocols and weak websites, and it helps to test against them, make them better. And it also is a good way to find a lot of interesting flaws out there in the wild. So, those stored credentials, that's a big no-no. That's a sensitive data exposure. Here's another example. About a month ago, I was testing against a client of mine, and they were a healthcare provider. Now, I went to their website, navigated to a directory, and that directory was a backup directory. That never should have been exposed. Guess what that backup directory had? An entire zip of their whole website. Now, the source code, every single thing behind the website. I downloaded that file. It was available to the entire public. Downloaded that file, and inside were, again, the source code, credentials, SQL database credentials, all kinds of stuff. That's things you do not want out there. So that's another example of sensitive data exposure. So if we scroll down just a bit here and we look at the different preventions, honestly, you want to make sure that your data is necessary to be on the application, right? You don't store data if you don't have to store it, right? Don't store sensitive data unnecessarily, as this says. Make sure that your data is encrypted at rest. Wherever it lands, make sure that it is encrypted. We don't want to just be able to access a file and everything's in clear text. Make sure that your files are not just in a directory that's accessible by anybody, right? Make sure that you are using strong passwords. Make sure you're using good protocols. And it says here, it talks about HSTS. We'll talk about that briefly in the next video, just about headers and why they're important. And we'll talk about it as well in the testing aspect. But there's also example attack scenarios. I think you probably get it by now, right? Like it's sensitive data exposure. There's so many different ways that this can happen, and there's so many different things that this can fall under. But what it really boils down to is your enumeration ability. What are you looking at, and how well can you sift through everything that's on that application? So the better investigator, information gatherer, enumerator that you are, the better off you're going to be. I've been saying that this entire course, but this holds true for a lot of web app testing, because it's not just cut and dry, here's the data. You might have to dig deep for that directory. You might have to read through 100 JavaScript files to find those stored credentials. It's not always just plain as day right in front of you. Sometimes it is, but not always. So that's a good overview. We're going to go into the next video where we actually do a little bit of testing for it. I'm just going to walk you through one of the examples, and we'll talk about some other things in terms of security headers and why they're important and what we're looking for. So that's it. I'll meet you over in the next video. So I've gone ahead and just pulled up the sensitive data exposure portion of the guide. And you can see it's pretty much gaining access to confidential information, unwanted information, finding a backup file, etc. And this all boils down to enumeration. Just like I said before, a lot of this is enumeration or discovering an item that should not be exposed. And that's really what it is. So everything that I've given you so far in terms of tools and techniques is available to you to actually, attack this and try to find things. The one thing that I can say is we'll walk through this just one here. And if we did a quick dir buster against this website, we would find a directory on here called FTP. And guess what? FTP has a bunch of different files in here, including backup files, KDBX, which is like a key storage database, right, for your passwords. Quarantine, there's different kinds of malware stuff in here. So, there's a lot of interesting things in here. And this is just one of the data exposures. But this is what I'm talking about. Like when I told you in the last video that I found a backup folder of literally the backup of the website, that happens. The other thing to point out is, coming into here and you just need to dig into every single folder and read what's going on in the response. Every response is important. You have no idea what you're going to find. And just looking through here, like you could search at the bottom something like password, or you could search for key or keys. I always search for those and try to find anything related to keys. And it just takes time to go through these and look through all the different responses and see what they're doing. And like, especially JavaScript, if you can get JavaScript to pull down with the response, that's always good. And yeah, that's really it. So the one thing that we're missing here that I wish that we had, but I could still show you, is this dashboard, like I showed you with the active scanning. It also does this passively for us. So this is what's really nice about Burp Pro, is it's good at finding what I call the low findings without doing much of anything. And one of those is something like response headers. Now these response headers are important, and it's also good at finding looking at the cookies as well, which we'll talk about that when we get to cross-site scripting. But the response headers are important because we can see what kind of protections they have here. And these different protections are, how we can defend against certain things. And one of the defenses was something called HSTS, which stands for HTTP Strict Transport Security. Now that is a header that should be set in order to prevent an attack where we take secure data, say HTTPS, we strip it, and it's called a protocol downgrade attack, and we make it HTTP. And then guess what? All of your encrypted data is now unencrypted. So there is a header out there that is called Strict Transport Security. Guess what? I'm not seeing it on here. You would say Strict Transport Security. Because of that, that means that HSTS is not enabled here, and we could attack this website with a downgrade attack. Now that is a man-in-the-middle type attack. It's not something that's necessarily easy, but it's something that could be performed and is reportable to a client. And a good website for this, if you're testing against something that's externally facing, which we're not, so we can't do this, but securityheaders.io or .com works, either one. You just come in here and you scan a website. And for example, we can scan tesla.com, and you can take a look, and it gives you a report right away. It says C. Okay, and it comes through here and it says, here's all the different headers, which remember we looked at the headers and we saw all the different weird Tesla headers. This isn't really common, but you come through here and it says, hey, look, you're missing this header, and this header. And you have these headers here. Look, here's the strict transport security header that we're talking about. And you can come through here and see it. Like here it is in green. They have it. That's good, right? But they're still missing some headers down here. So I always like to take screenshots of what they're missing, so that way they have best practices and what they should be including. So this is just another way. It's not necessarily sensitive data exposure with the security headers, but it is when we include the HSTS. So you should be considering and thinking about security headers as well when you're doing these sorts of searches. One other thing to point out is that we should also be looking at the level of encryption on the website. Now, there is a tool that we can use for that, and it's called Nmap. It's a great tool, and we can use it to scan a website and see what level of encryption they are and get a rating or report back. So let's take a look at that. So what we're going to do is I'm just going to new tab here. And again, since we're not using HTTPS on this site, it's not going to be relevant. So I'm going to scan this against Tesla, but we can just say something like nmap, and then we could say script equals an SSL enum cipher. So we're looking at the ciphers and how strong their ciphers are. And we could just say port 443 tesla.com, something along this lines, okay? Hit enter, and it should just take a second to come back, depending. It's gonna go out, pull down all the SSL information, and then drop down a list of information back to us, and it's gonna say, hey, it's gonna give it by grade, like A, B, C, D, F. And so go ahead and let this scan. If it takes a second, go ahead and just pause the video, and then come back when you're done scanning. Okay, so we're back, and you can see the least strength is an A. This is fantastic. This means that Tesla goes in there and they really take care of business. If we were to see like an F or even a C, we would probably report this. Like if they have bad ciphers, that's reportable. Again, it's a low finding, but this has to deal with that sensitive data exposure. If we can attack a cipher, and again, this is a very complicated attack, but if we can downgrade, something like SSL or TLS, whatever, we can overcome, the encryption, and we can then we can get the sensitive data exposed to us. So it's always good to check for this as well. These are just best practices kind of as we're going and we're mentioning these that we should be checking for. So I know this can be a lot and a little bit overwhelming, so please, again, take notes. I'm going to keep harping on this. Take notes, rewatch this if you need to, rewatch the entire web app portion if you need to. But make sure you're checking for security headers. Make sure you're checking for the SSL ciphers. This is two basic common checks that you're going to want, especially when you're writing reports up against a client and a website. So that's it for this. Next, we're going to get into XML external entities, which are incredibly fun and incredibly dangerous. So I'll catch you over in the next video. Number 4 on the OWASP top 10 list is what are called XML external entities. Now, this is also known as an XXE attack. So what is XXE? Well, XXE abuses systems or attack systems that parse XML input. So what you're going to see here in our example in the next video is that we're going to take XML input and get malicious with it. We're going to upload it into a upload file feature, and it's going to try to parse that XML input, and then we're going to be able to do malicious code with that XML input and get some information out of the system that we're attacking. And this will all make sense here in just a minute. Because of this, we're going to be abusing what's called a system entity. When we talk about XML here in a minute, you'll see what that means and how we can get malicious with it. And lastly, the attacks that we can do include denial of service, local file disclosure, which is what we're going to be doing, remote code execution, and much more. All right, so let's say that I want to write out this XML document, and I just kind of want to cover the basics of XML first, so that way you can understand why this attack is going to work and what we're doing with it exactly. So let's start by writing this out. Up at the top, I'm just going to type this out here, the XML version, and what this is what's called our metadata. Now, you don't always need this, but I always like to include it at the top. So if you go ahead and just follow along, and if you need to pause at any time while I'm typing this out, please feel free. I am going to try to talk slow and type fast. That way you can follow along and have opportunities to catch up. So at the very top, we've declared that this is an XML document. And what we're going to do with that is we're just putting this header here. We're saying, hey, the version's 1.0. Here's our encoding. And then we're going to need to declare what is called a root element. So we have elements, okay? And so we're just going to say gift. In this situation, we're giving out a gift, okay? So here's our root element, and I'm going to do just like this. And if you've ever used HTML before, all you got to do is close off your tags here. So we've got this gift, and then we're going to say /gift to end this element. So up here, we're going to go ahead and just hit a tab. And let's say that we're giving out a gift. And to give out that gift, we're going to need to say, hey, we're going to do 2. And I'm doing this gift idea because if you see at the top, it is December 21st. It's almost 1 a.m. here. So it's really close to Christmas or whatever holiday that you celebrate. So I thought this would be a good idea. So we're going to give this gift to our buddy Frank. We did him dirty in the 80s section. We owned his account. He had bad passwords. So let's give him something nice to say thank you. And we're going to say from, you can go ahead and put your name in here, close off the from, and then we're going to go ahead and just give him an item. So the item I'm going to give him is Pokemon cards, because who doesn't love Pokemon cards, right? So we have the gift, which is our root element. These are what is called our children elements. Okay, so remember that we have root and children. Now let's say we're in a situation where I've got a lot of gifts I want to give, and I don't want to have to type this over and over and over again. Well, then we can use something that's called an entity, which is basically it's like a variable. So let's go ahead and take a look at that entity. So to add an entity, we're going to say something like this. We're going to declare doc type up here, and we're just going to call out gift, and we're going to say entity from heap. And this will make sense in just a second, so go ahead and copy that out. So what I'm going to do here is I'm saying, hey, I have an entity and I want to call that. And when I call that, I want to go ahead and place Heath there. So again, like a variable, right? Wherever we call the variable at, it's just going to place this there. So we're going to say from, like this. Okay, so we have ampersand from and then semicolon, and that calls it. Now, why is this also interesting? What is this doing for us? So a couple things here to point out. What we have here, this doc type, is what is called a document type definition. That is a DTD. You will hear that again, DTD. So we are declaring this entity within the DTD here. Now, we have a lot of gifts to give away. We can use from repeatedly, right? Well, let's say we're in a situation, I'm just going to add some spaces in here, where we don't have from, but instead we just had something like Heath, and maybe there was, another person like Amber that I wanted, that the gift was from multiple people, right? So I could say Heath plus Amber, Heath and Amber, Heath / Amber. Well, the thing here is if we had just that in here, that's not going to work out for us. These characters a lot of these are just forbidden characters. So we can put in, alphanumeric, but when it comes to these special characters, it kind of gets funky. And imagine if we wanted a special character like, I don't know, a greater than symbol or less than symbol. What's that going to do to our code? That's going to mess things up. So what we can do is we can use these entities to call things down. So if I put in here and I said Heath and Amber, guess what? That would actually bring down as long as I declared it here and I said from. So not only does it work as a variable, but it allows us to include other items, right? Special characters. And if your mind's spinning, you've got that attack thought process. What does that mean? Well, that means that we can add things in like, I don't know, /, maybe try to grab a file, maybe a colon in there too, something something along the lines of like C/, maybe try to give a file out, right? So let's take a look at something here. I'm going to show you a payload. So let's go out to Google, and I'm just going to say Google, and then I'm going to say XXE payloads. Now, I do this with a lot of stuff, by the way. You're going to see me do this over and over. I love to just go look up payloads because there's so many things out there and I can't remember everything. So I open up a couple of these. Let's look at the payloads, all the things here, and just kind of scroll through it. And what I'm looking for is the classic XXE. That's what we're after here. So the file system that we're attacking is either going to be Linux or it's going to be Windows. We are after a Linux system. Why? Because we're running on Docker, right? On our Linux system. So we're going to run in Docker on our Linux system, and we're going to attack the XXE password. So what we're going to do here is let's just copy this one down. And I'm going to copy this one. And actually, let's copy the second one. This looks more like what we did before. Let's copy the second one. And I'm just going to delete all this out of here. And I'm going to paste this in. So this looks familiar, right? Exactly what we just did. We have our doc type, and we declare an element inside the DTD. Okay? And then we also have an entity of XXE, and we're calling out the system here. So before we were declaring, we were just, saying, hey, it's Heath, entity from Heath, right? Well, here we're adding a little bit extra. We're saying system. And system is a keyword used in an entity to let the parser know that the resource is external and should be stored inside the entity. Okay, so this allows us to put this kind of content here maliciously into it. What also does system do? Well, it allows us to pull data from the system. So what we're trying to do is we're saying, hey, entity XXE system, and then go ahead and pull the XXE password file. Let's try that. And then so when we have here, we have our child and we call out foo, or our element that we call out foo, then we're going to say, hey, I want you to go ahead and put in here the XXE, which is going to just be a placeholder for system file XXE password. Now, hopefully that all makes sense. In the next video, we're going to go ahead and take this, and we're going to get malicious with this and actually attack the upload and see how this pulls down for us. So let's go ahead and move on to the next video where we actually exploit XXE. All right, now we're on to the attack. Now, unfortunately, this attack is going to be theoretical. I'm going to walk you through every single step that we would take all the way through the exploit, but the exploit's not going to trigger or fire because we're running in Docker. Now, the issue here, if we scroll down, and you can see it says, please note XXE challenges described are not available in Docker container or Heroku. So the other methods that are available for installing are incredibly complex, especially on a Kali machine, and it's just not worth setting everything up for a course and going through all the trouble just for one demonstration. So I'd rather just show you kind of how it's done, walk you through it, and then show you the picture of what it would look like if it triggered. I think the methodology here is important. So looking at our exploit, all I've done is saved it. I put it on my desktop. You could put it wherever you want. You can call it whatever you want. Mine is called test.xml. And again, we're calling out this file XXE password, and we're going to do it for the and XXE here. So from here, let's go ahead and go over to our Juice Shop application. So go ahead and go to account and log in, and let's make a new account. So we'll go ahead and just not yet a customer. Let's go ahead and do that. And we'll just call this test. I'll call it testing at test.com, and we'll just say test123, test123. And then our eldest sibling's name is Bob, or middle name is Bob. So log in there, or register there, and then let's come in and log in. And then we're going to go ahead and take a look at the application. Now, this is what is called authenticated testing. We are at a middle user or a regular user between here from unauthenticated to an admin. So we're kind of in between, right? On this account, we should navigate around and see what we have access to. That is my first methodology when I get access to a user account. And if you're doing web application pen testing, again, you're going to be given two accounts, usually two roles. One is going to be admin, one's going to be non-admin, and you're probably going to test unauthenticated. Now, I've seen a bunch of roles before given as well, but typically it's two. Sometimes there'll be more. But what you want to do is go around and see what you might have access to, right? Where are your pages? What screens do you have? What can you do? And I like to go through and just, click on anything and everything that I see a link for. The nice thing about Burp Suite is with Burp Suite, we can come in here and we can go right click and scan if we had the pro version, which if you're doing pen testing, you will. Your job should pay for it. And so you would do scan, you would crawl the website, and it would find a lot of these links for you. So it doesn't hurt to navigate around. It doesn't hurt to understand the application, how it's running, what it's doing. That way you have a good feel for it, right? So from here, we're just going to abuse an upload feature. So if we go to the complaint section over on the left side, we see that there's a file upload feature. Now, anytime I see a file upload feature, I kind of drool a little bit because I get really excited about it. And file uploads can be very devastating if they're not handled properly for a web application. On top of things that we've already seen before when it comes to file uploads and executing malicious content on websites through the middle capstone of the course, right? We here can also upload XML files, and we can upload malicious documents and try to dump sensitive information, get a shell. There's a lot of things that we can do. At a bare minimum, we should see if the upload feature is functioning the way it is. Even if we can't get a shell or get anything out of it, can we bypass what it's trying to do? So here you're going to see that this is going to be trying to only allow for zip files and PDF files, but we're going to upload an XML file, and it should blacklist it, but it doesn't. Okay, so let's go ahead and go to browse, and we're going to go to root or desktop for me. And then you're going to see here, it says all supported types. Well, all supported types are PDF and zip, but I'm just going to go all files and say, I want to do the test XML anyway. And I'll just say test. And what's going to happen here is I'm going to go ahead and intercept this request. And I'm doing this because I want to see the response in case I need to tinker with this. So let's go ahead and submit. And then I'm going to send this to repeater, and we can take a quick look at it. So in repeater here, you can see that we have our test.xml being uploaded, and the XML version 1.0, same thing. We have our XXE entity, and we're just saying, hey, I want to call system, and I want to call this file from XXE password because we are attacking a Linux machine. So here we see the call of the XXE. We would execute this, and if this were a real web page that was vulnerable, you would see some sort of printout of the XXE password file. Now, I have a video of this on my channel on YouTube that I'm just going to show you a quick picture of. I'm going to show you a stopped image. So if we see here, when we cover XXE, you can see that right here in the juice shop, look what came through. You see this part? XXE system quote file, and then guess what? Once it calls that ampersand XXE, you see here root, you see user sbin, and it's cut off. It only allows for so much. We'd have to finagle this a little bit, but this right here, you could submit to a client, you could submit to a bug bounty program. You can say, look, you are vulnerable to XXE. This is what it is. So what's going on here are these DTDs are being allowed. These external entities are being allowed, and through this parser, and we're able to just push this through. So what is the solution here? How do we defend against this? Well, we need to disable completely these DTDs, these external entities. Once we disable that, you're not going to see this come through at all. And it's going to look almost similar to what you're seeing here. We just don't have the ability in Docker to do it. Okay, so we would never know. If I saw this when I tested it, I'd be like, well, okay, that exploit didn't work. I might go more through those payload lists that I showed you and see if we can't get that to work, or try different things to see why it's not working. You should never give up on the first go, but at the same time, this isn't showing me that it is exploitable, where if we looked at the other image, it did seem like it was. So hopefully that is a good example for you, understanding how and why we did this. We're taking and abusing the XML feature, the XML parsing feature of a website. So because of that, we're able to upload a malicious XML file and bypass, by the way. So this bypass is a finding. Regardless if we had XXE here or any sort of a malicious ability. This is a finding in itself, and this is a pretty big one because we're bypassing what whitelisted extensions they had originally. So I would mark this up as a finding, and this would actually be even something that you could submit on a bug bounty program to get a bug or money from it. So that is it for this lesson. So we're going to go ahead and move on to the next one, which talks about broken access control. I'll catch you over in that video. Let's talk broken access control, which is number 5 on our list. Now, broken access control is kind of like this big catch-all. There's so many different vulnerabilities that can fall into this. And you can see, scroll down here, and you can see there's quite a bit. What you need to know about broken access control is you really should know what it is at a high level. And that means that a user gets access to somewhere they shouldn't. It's as simple as that. Say, for example, that we have here a page and there is an admin section. And we're not an admin user. We should not be able to access that admin section, right? That would be broken access control if a regular user like me is able to access the admin panel of an admin. Or another one might be something like ID equals, and then we say something like 5, and we're viewing our record or our page number of 5, and we see all of our details and data. Well, we could reference a different object, maybe 6, could be a different user ID or a different page, and we see that, but we're not supposed to see it, right? That's a vulnerability. That's broken access control. So there's so many different ways that we can exploit this, and I'm going to show you one. But I want you to know, what I want you to take away from this is the high level of what you're looking for, and that is to be able to bypass access. We could do probably hours of material on just this concept, but you are looking and thinking like an attacker, right? So this is why, specifically why we have, when we're talking in the last video, we have those 3 tiers, the unauthenticated, authenticated, and admin, right? You want to know if you can access admin areas or even other user areas from an account. You want to break that access. That's how you find these vulnerabilities. So there's a lot of different ways to do this. What I'm describing here is good examples. You can, like it says, access a web page like we just talked about, or what I'm showing you, going from 5 to 6, that's what's called an IDOR, or an insecure direct object reference. We shouldn't be able to see somebody else's information unless we're meant to see it. Okay, so I want you to read over this page, and I want you to get familiar with this, kind of understand how to prevent. So everything's a little bit different depending on the vulnerability and how you should prevent it. But what it boils down to is that you need to ensure that your users do not have access to anything that they should not, right? So let's go ahead and take a look in the next video at an example, but I want you to read over this, get familiar with it, be able to understand in an interview, what you're after. If somebody says, hey, can you explain broken access control to me? You say, yeah, here's an example, or here's another example. So read through this for sure. And then again, as always, I'll post the reference down in the reference below for this website. So I'll catch you over in the next video and we take a look at something that I find quite often in web apps. All right, now on our application. I'm already logged in as my testing@test.com user. So if you're not logged in, go ahead and do so now. We're going to abuse one feature, and I do encourage you to come in here and look at all the different broken access controls that they have and just kind of get an understanding of all the different ways that you can manipulate things here, okay? And gain access to places that you shouldn't. But the one that we're going to be looking at is putting feedback in another user's name. This, when I show it to you, I'm going to explain to you why I like this one, because it's a nifty little trick that you're going to see here. So let's go ahead and go to account, or actually let's go over here and go to customer feedback. So our goal is to leave feedback in another user's name. So I'm going to say mean things. You're terrible. I'm going to make this person look bad. I'm going to give a 1-star rating. Let's go ahead and solve the CAPTCHA using our PEMDAS, right? So 6 minus 5 is 1, plus 9 is 10. And if we submit this, we just submit it as ourselves. Well, we have to understand what's going on here. So what we can do is we can right click on this and say inspect element. Now, why do I love this? And this might be hard to see, so just try to follow along. But I love this here because this is so realistic about what is about to happen. I'm so excited, I'm stuttering. So with what's about to happen here, a lot of times I'll log into an application or a web page, even like big name vendors I've seen this on, where you go in there and there's like a username and password field, or what's your security answer, and you see it and it's like all stars, right? Well, something I like to do is I like to inspect that element and see if it's holding the value there, but it's just hiding it or masking it from us, which is exactly what's happening here. So we inspected the element and you should be brought somewhere here like this div class. If we look up just a bit, there's this input user ID right here. And you can see that the text is actually hidden. So it says hidden right here. I want to go ahead and just delete that and see what is going on here and what text is actually hidden. And you see it says 18. It's a user ID of 18. They're just hiding this. This is not a good way to do this, right? This is terrible. But this, honestly, this is so true, is you have this password field just like this where it's all blanked out. You right click on it and it says hidden. You just set it to, you delete it, or you say false, or you want to show these passwords, or it'll say field type equals password, and you just say field type equals text. And guess what? It'll show everything in clear text. So this is a form of bypassing broken access control here, or bypassing access control. So we are user ID 18 in this application. I'm just going to go ahead and try to pick user ID number 1, which should be probably an admin or the first user created if they're incrementing these in numerical order. So let's go ahead and submit that. And you can see it says forge feedback. We have done it. So we just posted feedback in another user's name. That's broken access control. We weren't supposed to do that. Another example is, say we wanted to, I think it's administrator or administration or something along those lines here. If we wanted to try to navigate to that page, look, it had it for a second and it blocked us. So we need to try to abuse all the features here that we possibly can. So keep these things in mind, read up on this stuff, try to understand what's going on, and know that broken access control is a huge catch-all for a lot of different attacks, but understanding what it is for an interview process is going to be super helpful. So that's it for this. We're going to go ahead and move on to number 6, which is security misconfigurations. We're going to talk about security misconfiguration, which is number 6 on the top 10. And you're going to realize you've already seen this a couple times before. So we only need to do this one video. We don't have to do 2 videos on the topic. So let's talk about security misconfiguration. Again, kind of like number 5, this is just a big catch-all. If you misconfigure something in your security, then guess what? That's a security misconfiguration. And there's so many different examples of that. You can see all of them here in example attack scenarios. But let's talk about some of these, like a default credential on a web page. That happens so much. You will not believe. Just today, literally, no lie, just today, I was doing a pen test and I came across default credentials on an application. Those default credentials led to disclosure of sensitive information. Literally was able to view every single employee and view their employee email addresses, their employee ID number, their phone number. There was a lot of sensitive information there that should not have been disclosed, but it was because guess what? Default username and password. And we've talked about this before in the earlier videos when we were doing the mid-course capstone, but this is just something that you see so much. I see it all the time. I've seen things like Cisco on a router, and that allowed access into a network, right? So there's a lot of different little things like this where you find an application, you should always be checking for default credentials. Another one, stack traces, okay, error handling. We've already seen that happen. If you think about the error handling, when we tried the SQL injection, we put in that single quote, it threw an error. Your application should not be throwing errors, right? You should eliminate any sort of stack tracing. You should eliminate any sort of default credentials, right? And it says in here, unnecessary features are enabled or installed. Even like applications that are left behind, or you're able to navigate to source code, or you're able to see files that you shouldn't be able to see. Or there's sometimes their applications come with, certain features, but they're just default features and you're not using all of them, but you didn't disable them. Well, maybe those have vulnerabilities in them as well. And that would be considered a security misconfiguration. So, and at the bottom it says software out of date or vulnerable. Yes, that is part of it, but as what says here, using components with known vulnerabilities really falls into number 9. So we'll talk about that in a little bit. But again, this big catch-all where if somebody makes a security misconfiguration, which it happens all the time, then we're going to take advantage of it, right? So it talks here about the preventable measures, and it really just depends on the certain scenario. Like, you should be using best practices when you're installing things. Don't install, make sure things are not installed on your systems that you don't need. You don't have any unnecessary ports open or accounts activated. You're not using default credentials on your web pages. You're not allowing for stack traces or verbose error messaging. There's a lot of different things out there that you could do, but you need to make sure that your security is intact. And this one's really hard to do, right? Like, it sounds like, okay, we've got some things that we can work on, but that's kind of the whole point of a pen test, is to find the security misconfiguration. So a lot of the things that you're going to uncover are going to be a part of this. So we've talked about one that we've already seen, which is the error handling. We did the SQL injection. Well, another one that we've already seen and achieved on our scoreboard is the deprecated interface. So that is the file upload. We were not supposed to be able to upload a file, and we were an XML file, right? Remember, it was only zip, it was only PDF. Well, we uploaded the XML file, and that is a complete bypass of this. That's a security misconfiguration if we're able to bypass that, right? So that falls under this bucket as well. So again, another catch-all. But when you are asked in an interview, you can talk about these things. Again, the default credentials, the stack traces, directories or parts of applications left behind, unnecessary ports open, unnecessary accounts or privileges, or etc. And that should really help you out when you're actually in the interview process. So from here, that is it. We're going to move on to one of my favorites, which is cross-site scripting. So I'll catch you over in the next video when we start talking about what that is and the different types of cross-site scripting. Welcome to cross-site scripting. This is one of my favorite bugs to hunt for and to find. So in cross-site scripting, we really have 3 that we're going to talk about. And this is a popular interview question. You're going to get asked, what are the 3 types of cross-site scripting? Okay, so we're going to cover that. We're going to cover what they are, why they're a little bit different, and what they might look like in code. And then in the next couple of videos, we're going to exploit a couple of these. So as you see here, there are 3 types of cross-site scripting. We have one which is called reflected. Now, reflected means that it's reflected. We're going to inject something malicious. And what's going to happen is you're going to get a pop-up and it's going to be reflected to us, okay? It never gets stored on the server. So the server is going to read the request and then it's going to respond back with that request. And it's going to reflect on the page. Now, if we leave that page and come back to the page again, it's going to go away unless we make that request and be malicious again with it. Now, the opposite of that is what is called stored or persistent cross-site scripting. What that means is we inject a malicious payload and then it is stored onto the server. So we leave, we come back, and that payload is still there. Okay, so we have a stored capability. And you're going to see in this course, you're going to see a reflected and a stored. Now the last one is what is called DOM. Now DOM stands for the Document Object Model, right? This is in JavaScript. So what's happening here is when you are going out and you're injecting this. So when you go out to a website, the server is going to show you some HTML, it's going to show you some JavaScript, it's going to send it back to you in your browser, right? And when you see this and when you want to modify this, it's called the DOM, the Document Object Model. Now we can exploit that DOM, and this again is going to be client side. So reflected and DOM are both client side, and we can attack specifically the DOM. And I'm going to show you more of how that works and what it is here in just a second. But those are the three. 1 is reflected, 2 is stored, and 3 is DOM cross-site scripting. So let's go ahead and take a look first at reflected cross-site scripting. Okay, let's say that we have a PHP page, and we'll just call this index.php as an example. And let's just write out some PHP here. It's okay if you don't know PHP. I'm just going to show you some things. So we'll just declare PHP, and then we'll declare username as a variable, and we'll just say we're going to go ahead and get the username. All right. And when we do that, we're going to echo hi username. And then we're going to kill this. So that's it. What are we doing here? Well, let's say we have a situation where we have index.php and it looks something like username equals Heath. Well, what's going to happen here? It's going to say, hi, Heath, when you come to the web page, right? Okay, well, what if we have something like index.php and the username instead is something like this, script alert 1 script. Well, guess what? That's going to run JavaScript. Okay, we're declaring that we're running JavaScript with these script tags, and we're going to run what's called an alert. Alert is going to bring a pop-up up on the browser, and it's going to pop up and it's going to say 1 on the pop-up. And this is classic cross-site scripting. All right, so that is what reflected looks like. This would be an example of reflected. Now imagine stored. The best way to describe stored, we don't even have to look at code, we can just think about it. Think about having a blog post and you can go comment on that blog post, or having a form and you can go comment on that form, right? What if you were to leave something like this script alert 1 script and you left it on a blog post? Well, every time if the site was vulnerable, every single time you went to that page or anybody else went to that page, then guess what? They would also see that pop up because it's stored on the server side, right? So there's some difference here to talk about when it comes between reflected, well, really reflective, DOM, and stored. Reflected and DOM require social engineering. We have to get somebody to open a malicious link, and that malicious link might point us or point to us as an attacker. We might have some sort of JavaScript that we're running, and that JavaScript is going to execute. It's going to it's going to steal a cookie from a user, and it's going to send it to us. And we have their cookie. We're going to go to try to log in as them. But we need to be able to know the user and then send that well-crafted link, social engineering, and get that cookie stolen, right? Now, if it's stored, we don't have to do anything. We just put a malicious JavaScript in, and we're not going to make it a pop-up. Pop-ups are just used for an example because they pop up, we can see them. But if it's stored, we might have the same feature where it's stealing a cookie. And that cookie gets stolen, it comes to us, and guess what? You're going to the page, you don't even know that it's there. You're not looking at the source code, you have no idea what's going on. It's just sitting there stored in that page. So we can be really malicious with that. There's a lot of different things that we can do with cross-site scripting. including stealing cookies is really the big one. We can do key logging. We can do denial of service. We can deface a web page. There's so many different things that we have options with. The most common and the best examples are stealing cookies and doing this JavaScript kind of pop up as a proof of concept. So that's what we're going to do with these lessons. Now, before we do that, I do want to point out one more thing. I want to point out this blog post on DOM-based cross-site scripting. Now, DOM-based is hard for people to get their minds around. It's not one that you find very easily. It's kind of complex. And I really just want to give kudos to this author who talks about DOM-based cross-site scripting and can explain it better than I can. I'm going to walk you through what's going on here in the code and how you should be able to understand what you're seeing here. So there's two things that we need to talk about. There is one what is called a source, and then the other is called a sink. And you can see them here identified in the code, okay? Now a source is where you insert malicious input. So that's where your malicious input goes. Your sink is where it is executed. Okay, so we have a source and a sink. Now, what's happening here? Well, we have our source and it says, this is just a variable called source, and it says hello, and then they're just putting a hash here, okay? Because this decode URI is just saying, hey, we're gonna put a hash here. A lot of modern browsers nowadays will obfuscate this or try to prevent cross-site scripting. So it's just gonna say, hey, allow this hash, and we're gonna say, okay, we've got the hash. And what's going to happen then is we are also going to execute our code here because this is the source. So if you look down here at this vulnerable get, we've got the hash at this example website. Okay, we've got the hash, and then we put in this. What they're doing is they're putting in an image with a source of test, and there is no image that's called test. So on the error of that image not loading, it's going to pop up an alert box and say cross-site scripting. Now here, in the DOM, we also are going to have the sink, okay? So this div element in our HTML is going to be our sink. That's going to pull this all down for us, and it's going to be executed right here. So this is all happening on the client side. This is a great example of DOM-based cross-site scripting. Again, this is something that you're going to have to pull off with social engineering, just like reflected. You're going to see DOM-based the least, in my opinion. You're going to see a lot more reflected, you're going to see a lot more stored, and a little bit of DOM-based. Okay, so you have to understand this. This article is great. It tells you where a bunch of sources are, where a bunch of sinks, talks about defenses. I think this is one of the best articles that I have read, especially when I was a beginner, and I like to pass on those articles as well. So I'm going to be putting this down in the description. So from here, hopefully that was a good overview of what this is like, okay? So hopefully this is a good overview, and now you know, all you need to take out of this right now is, okay, there is reflected, there is stored, and there's DOM-based. And when you think of reflected just means that it pops back to you, but if you were to leave the page and come back, it would be gone. Whereas stored, if you're to leave the page and come back, guess what? It's still gonna be there. So in the next video, we're gonna do an example of stored. Okay, we'll do a stored based, and then we're going to go ahead and cover a reflected one, and we should be good to go. I'll show you all the different types of cross-site scripting ones they have, and there's even a nice walkthrough for the DOM, which I want you to do on your own and kind of get some experience and see how it's done. And I do encourage you to also look through the other ones and see how they're done as well. But for now, let's go ahead and go into stored, and then we'll move on into reflected. So I lied just a little bit. I actually want to cover reflected cross-site scripting first because it's going to be a tad easier here. So I want to first cover the scoreboard, and then I want to cover the methodology, and then we'll talk about the actual reflected cross-site scripting, which again in Docker, it's not going to allow us to perform, but that's okay. I got you covered. I'll show you an example of it elsewhere. So here, if we go into our scoreboard, let's take a look at the scoreboard really quick. And we sort down here by cross-site scripting only. We have all of our options. Now we're going to be covering reflected, and we're going to be covering the stored, okay? So there's classic, stored, and reflected. You're welcome to go through the rest of these, read the write-ups, see what's going on. The one I do want you to focus on for the scope of this course is I want you to focus on the DOM cross-site scripting. Guess what? There's an interactive tutorial for this. That's great. It's going to teach you how to do this step by step, and I think it's perfect. So the nice thing here is they give you the payload, or at least the payload on how they want you to start. So you can copy this payload and try to use that around the website and see what's going on. I'm going to go ahead and copy this. Now, what I would do if I were pen testing this website, I would come through here and I would inspect anything and everything that had an input or a parameter. And this is a good place for Burp Suite as well. Burp Suite's pretty good at actually finding reflected cross-site scripting. So again, that crawling aspect and then that active scanning aspect is really nice because it might pick up some of these. But what I'm after is something like, for example, this banana juice. And I want to look at the reviews for it. Okay, well, look, there's a review box here. What if I tried just, I don't know, pasting this in here and submitting it? Well, okay, it's in here, but nothing's happening. Let's close out. Let's try to open it up again. Still nothing. And, this is a good example of stored. So in terms of storage, right, this is happening on the server. This is now stored on the server, but it's not executing anything for us. That's fine. Okay, well, it doesn't work there. Maybe a search bar, maybe I'll come up here and I'll paste it and I'll hit enter and maybe something will work. Ah, what do you know? That worked. That's a DOM-based cross-site scripting. Don't do anything. Go read the walkthrough, follow it along again. But look at that. That was that easy, right? You can find it that easy. So you can come through and maybe, there's the complaint form, the about us, photo wall. There's different things. What about in your account when you go to testing and you say, oh, look, I've got a username here, or I've got a URL or something here that I can put. Maybe you want to set a username. You say set username. Oh man, look, they took out our part of our code. We had the iframe src, but they removed part of it. So it looks like they're filtering stuff here. And we'll talk about that later. But the point that I'm getting at here is you want to attempt to attack any parameter that you can. Okay, so you want to click around. If there's a field you can insert something into like this, that's a good one. If you come up here and you see something like this, that's a spot maybe you want to try it. Or again, if you see, remember the reflected example where you saw question mark equals, you might want to try that too, where you just insert the iframe and see if you can get it to work. So there's lots of different places here that we can try this. Now what we're going to do is we're going to take a look at something called cross-site scripting game. And what it's going to do is just allow us to practice. So if you go out to the web, and I'm just going to open up a new tab, and I will submit this again for you guys. This is the address, xss-game.appspot.com, and go ahead and hit enter. And if for some reason this does not work any longer, then just understand that how this is working and what we're testing for and why it happens is just as important as actually getting it to execute on your side. So unfortunately, again, we can't execute on Docker for this specific vulnerability with cross-site scripting. So this application itself is kind of weird in the sense that it allows us to have some, and depending on the different type where we're running it. So here, cross-site scripting, and it says level 1, hello world of cross-site scripting. So let's go ahead and just get a pop-up on here. Again, it's a search bar, right? And we're just going to talk about an example. We'll say script alert 1, or alert, 1 like this, and we'll just say /script, and we'll give it a go. And I'm going to copy that and hit search. And look at that. It went ahead and searched for us. And it gave that pop-up. And we have that question mark query equals here. And you see now that we've got this pop-up. And that's really what a reflected would look like, okay? You would see reflected here, and it's going to reflect, and it's not stored anywhere. So if we left and came back to the page, guess what? It's not going to be there. And if we try here, maybe this is looking like a stored because this is a comment post, right? We come in here, oh, it obfuscated it. Well, maybe we're not good enough here to figure out quite yet. This could be a game that you can definitely come through and play and see what's happening. And let's go again. Maybe this is had something for us, but it didn't. So this is just an idea here. You can come play with these games, see what it looks like, but all we're after is that pop-up, and you got to see what that looks like. Now in the next one, it's going to be a little bit more fun and a little bit more engaging because we actually get to mess around with not only a stored cross-site scripting, but a stored cross-site scripting that we have to think about to actually figure out. So I'll meet you over in the next video when we start talking about stored cross-site scripting. We do a little bit of bypassing. So I'll see you over there. Now on to stored cross-site scripting. And this is the big one, right? This is where you really can prove impact and you can make some good money when it comes to bug bounties as well, if you think about this. So think about it in this sense. Say there's a comment form or something out there and you post a comment and that comment can affect an administrator. You as a regular user can infect an administrator. Now you as a regular user have stored this vulnerability that steals cookies. You steal the administrator's cookie, you hijack the account, and you log in as the administrator. That's how this can become very dangerous very quick when it's stored. So here we're going to look at what we were looking at last time. And actually, let's go back and go to the scoreboard before we move on. And we're going to just grab the payload recommendation, okay? So go to the scoreboard, and we're going to say, okay, we're after the classic stored. So it says perform a cross-site scripting attack with script alert cross-site scripting script. Let's go ahead and just copy that. And I'm going to point you a little bit in the direction where we already were. Let's go to our account and our testing profile. And let's try to set our username using this payload. And look at what we have as a payload and look what returns, all right? So we've got script, LERTXSS. Okay, well, what just happened? They took off something, right? What did they take off? They took off script A. So I'm going to space this out here. To me, what this looks like is it's filtering this whole thing, right? It's filtering script A. So we need to think about how can we maybe bypass this? And there's a few different ways that we can do this. But what we really want to do is we want to say, hey, what can we do here to where we can start this, have something maybe filter out because it identifies it, and then maybe because it doesn't identify the rest, then we can go ahead and just, put the rest over here. And I wonder actually if I delete this just here and I say set username, does it keep that? It does, right? So it's looking for something here very specific that it's going to filter out. So why don't we do something along the lines of maybe, I don't know, let's look at this. Let's say we put our script back in here and we'll just close this out, make it look like it was. And then let's go ahead and just put script A back in here, right? So what's going to happen is it should say, hey, I've got this built-in mechanism, security mechanism that gets rid of script A. And then I'm going to go ahead and just leave the rest. But guess what? When it leaves the rest, this is all going to fill back in, or it should. Let's go ahead and take a look. Oh, look at that. Stored cross-site scripting. Okay, so it's now stored here, okay? And that's really cool. Look, and it says classic stored. We go back to the account. Let's take a look. Oh, it's there again. This is stored cross-site scripting. I love this stuff. So this is a classic example, and I love this one because it shows you a little bit of thinking outside the box. And once you get into web application pen testing and you really start to dive into the weeds, you're going to understand a little bit more that, there's all this different kinds of obfuscation that you might have to use in order to actually execute these payloads. And something that you might need to think about is running something like this maybe through Burp intruder. Say you have intruder here and or a proxy, we intercept, we say set username, we come in here and we send this over to repeater. And then in here, maybe we'll say, or actually, sorry, we send this over to intruder, and over here we'll say, go ahead, positions, I want to set this specifically, and then I'm going to go ahead and run payloads here. Well, how do we get payloads? We just go to Google, and that's going to hang because we got the proxy. We just go to Google and we say something like cross-site scripting payloads. I literally do this. This is what I do. Okay, so this is my methodology, spot on. You come here, you click the first one on GitHub or one of these other ones that you might want. Look at all these different ones here. You can copy all these, come through, try to grab it, you know, and see if you can't get one of these to pop. So food for thought, how you might try to get this to work. And even like things like this, look at all these different obfuscations. Look at this one here. Okay, it's using, you know, uppercase and lowercase because maybe it's just looking at that lowercase script A. So we can maybe try that one. Or they start getting into, you know, these weird HTML inserts, or you might even have like URL encoded, and these all look very different. And you'd be surprised, something like this, I've gotten something like this to pop before, just because it's obfuscated more so than, you know, just the regular type of payload that we would use. So as a test, I've actually never tried this out before. Let's set the username like this and see if it works. It doesn't. So it's actually converting this to lowercase, or it knows how to filter this out in the first place. So good on them. But again, thinking outside the box here is just the way to do it. Having these payloads, maybe firing them through Intruder and looking at how they look, what they might, you know, what the responses are and how it might store is always another good move as well. So just keep your wheels spinning. Go ahead and go do that DOM-based cross-site scripting next. Once you have all those through, go ahead and meet me in the next video when we talk about the defenses and what we can do to prevent these kind of things. And then from there, we'll move on into the next vulnerability. So I'll catch you over in the next video. Let's quickly talk about preventing cross-site scripting. So how might we prevent cross-site scripting? Well, there's a few different ways, and this isn't even everything. But let's talk about this. So first we have encoding. Now encoding is converting a control character to its escape sequence. Okay, so for example here you see that we have the less than symbol becomes the ampersand LT and then a semicolon. So if we had script, then script would just become ampersand LT semicolon script, etc. You see the example. Okay, so we're doing that so that these symbols are not interpreted for, like, example, an XML tag, or in this situation, the script itself. You just can't interpret it. We can't use that character anymore, right? And that's a very common way of doing things. Another thing is filtering. So where you just take script and you strip out everything and anything, and then it just becomes script. So any of those characters that you don't want in there, they just get wiped out, basically, right? So we say, hey, we don't want that, we're gonna take it out. Another one is validating. So that's comparing input against like a whitelist or a set of known good numbers. Say, for example, you have an account number and you type in the account number. Well, if the account number is not in a set of known good numbers, then it's not going to validate, and it's going to prevent that from even reaching server side, right? Or reaching an attack level. And then lastly, there's sanitization, which is basically a combination of everything. And that's really what you're after, is this combination of encoding, filtering, validating, and making sure that this malicious activity and malicious code cannot be injected into your website. So special note goes out to the HTTP only flag. So if you've been paying attention in Burp Suite and looking at your cookies, when your cookies get set, a cookie can have an HTTP only flag and a secure flag. We're curious more for cross-site scripting about the HTTP only flag, because its purpose is to prevent cookies from actually being observed by unauthorized parties. Okay, so what that means is if we do a JavaScript and we try to steal cookie via JavaScript, if we have that HTTP only flag, we're not going to be able to see that cookie. We're not going to be able to steal that cookie. So that will also help prevent this. So there's a bunch of different things that we can do and help guide this along. There's also headers out there that are cross-site scripting best practice headers that we can utilize to help prevent this as well. A lot of modern browsers are starting to help out here and prevent these. So this is a very, very common exploit that you see. And I would say out of all the things that I have found the most bugs on, it's probably cross-site scripting level would be up there on the number one for me. So you'll see this all the time. So that is it for cross-site scripting. Hopefully you learned a bit here, and you just take away, the big takeaways are what it does, why it's malicious, and the 3 types of cross-site scripting, which are reflected, stored, and DOM based. So from here, we're going to talk a high level of insecure deserialization in the next video, which is number 8 on our list. We've only got 3 more to go. So I will see you over in the next video. All right, let's talk about insecure deserialization. And this topic is kind of hard to wrap your mind around as to how it works, because there's so many different ways that this could work. And unfortunately, we're going to have to talk at a high level because there's not really a good application out there that we can utilize, and we can't utilize our application for this attack. So this insecure deserialization, we have to talk about what serialization is and what deserialization is, all right? So when we talk about serialization, that is taking this data and we're going to convert an object into this format which can be put onto a disk, right? And it could be sent over to a network or through a network. So it can be serialized in a lot of different things. It can be serialized in XML, JSON, YAML. It can be serialized in binary, and it is, it's serialized and it's sent over. The opposite process of that is called deserialization. So that means we're taking this serialized data and then we're deserializing it, right? So once we get it, we deserialize it. So the process of a insecure deserialization attack is when we have something malicious. We take something malicious, we have an exploit, we serialize that exploit, and then the application takes that data and it deserializes it and executes it, okay? And why does this happen? Why does this work? Well, web apps are always using, shouldn't say always, they use quite a bit serialization and deserialization, right? So this is happening all the time. This is why this makes the top 10, is because we can utilize this kind of attack. So we can send it something serialized, and then it's going to take it and it's going to deserialize it and run it and execute it. Now, these are kind of hard to find, and there are so many different executables out there and attacks and different programming languages that this goes to, and software libraries, etc., that this makes it really, really difficult to just go out there and find it. But it doesn't mean that they're not out there, okay? So I definitely encourage you to read up on this. There's all kinds of cheat sheets on how to look for this and scan for this. And really, it comes down a lot to known vulnerabilities and this how to prevent. It says here, that you shouldn't accept serialized objects from untrusted sources. That's true. That's the best case scenario when we talk about prevention. If the source is untrusted, you shouldn't accept anything, right? Because then we're going to send it a serialized object. The application is going to take it, deserialize it, and it's going to execute that code. And we don't want that to happen as a developer. Okay, so I encourage you again to read up on this. It is a complicated topic. It is by far not easy. And when you're talking about an interview process, which is what we're after again here, right? You should just know the serialization and deserialization process, what it's using. And then there is a tool that you can read up on that people use quite a bit, and it's called Why So Serial. So read up on Why So Serial and what it does and how to kind of utilize it. If you know that tool, you know serialization is, or what serialization is and what deserialization is, I think you'll be fine in an interview. This one is kind of, it's something you're not going to come across a lot, but it still belongs in the top 10 just for how, how deadly, I guess, it can be. So that's it for this one. We're going to move on to number 9, which is using components with known vulnerabilities. And then we're going to talk about insufficient logging and monitoring in episode 10 or topic 10. And then we're going to be done with the web app section. So I'll catch you over in the next video when we start talking about using components with known vulnerabilities. This is yet another high-level overview because I think we've covered this quite a bit in this course. So using components with known vulnerabilities, you're going to see this when it comes to network pen testing, for example, like Eternal Blue, right? Or any of the things that we covered in the mid-course capstone. A lot of those were just kind of run and gun, really easy vulnerabilities. You're going to see this in web applications as well. And there are different tools that we can utilize and go after searching for these known vulnerabilities. And you kind of saw it originally when we were talking in Burp Suite. And let's go back into Burp Suite here. And there's some tools in here, especially with the scanner tool, right? So the scanner tool is going to check for these out-of-date kind of applications. If you go into Extender and you actually have the Pro Edition, there's some more in here that'll allow you. ActiveScan++ will check for it. Retire.js over here will also check for potential vulnerable JavaScript libraries, and this software vulnerability scanner. Oh, also Java deserialization scanner. We just talked about that, right? So there's a bunch of different ones, additional scanner check, software version reporter. These are all part of the Burp Pro edition, and that's okay, again, if you don't have Burp Pro, but know that these exist over here in the Extender store. And, you know, if you're kind of, you know, doing it on the cheap, you can come into Wappalizer, look at it, say, oh, it's running jQuery 3.3.1. Let me go check out what that is. Or if you go to a website and you're running a scan and you see like, okay, this is running this version of this tool or this version of this backend, you know, you're going to want to research that and see if there's anything vulnerable for that web application. Another thing that you can do and probably will do is run Nessus against your web application. You're going to run it against it, not only to do vulnerability scanning against the web app, you're going to use more Burp Suite for that, but also to run it against the ports on that machine to see if there's any open ports that might be there that have vulnerabilities. But it will identify some of the software that's running on the website as well, and it will tell you if it's vulnerable if it finds out that and it has the plugin for it. So just keep that in mind. Like really, that's the high level overview. This is something that should be familiar to all of us, is that we should always be patching, right? We should not be using components with known vulnerabilities if we can prevent it by all means necessary. So and you see it mentions retire.js here. It's got dependency check. There's other things in these resources that we're providing that talks about it. Here it talks about Apache Struts 2. Guess what Apache Struts 2 was, by the way? That was a deserialization attack. Okay, so this is a very, very famous attack here, and it just talks about it. And you can go, and it's talking about Shodan here. You can go on Shodan, and if you've never been on Shodan, it's a great website where you can go out there and look up different vulnerabilities that might exist. Like you might be able to search for this specifically by a string and see, okay, well, wow, there's all these out there, these machines out there that are still vulnerable to this Apache Struts 2 or to XYZ type exploit, you know, and it's honestly a very scary thing when you do that, because just the other day I was looking at a bug bounty program and I said, well, there's this vulnerability that just came out and there's an easy way to search for it. So I'm going to go search for it and see what's there. And if any of these machines belong to a bug bounty program. So I did the research, just looking through it, and all these places that were vulnerable. It was sad, almost like hospitals, schools, government entities, all these things that were out there that were just wide open and vulnerable. And it's because patching is not kept up to date. If you're not patching, if you don't have an active patch schedule, you're going to be using these components with known vulnerabilities, and you're going to run into issues. So, you know, patching is very, very, very important, and it's going to show up on this list pretty much all the time, every time, because it just doesn't get done enough, and that's where we come in and we take advantage of it. So that's really it. We're going to go ahead and move on into insufficient logging and monitoring, and then we are done with this section. Lastly, we are touching on insufficient logging and monitoring. Now, again, just a high level overview, something that, you think, and you probably are in the security mindset, and you're just like, yeah, that makes sense. Why aren't people doing it? Well, it makes sense on the last one with patching, right? And people just don't do it. So we have that mindset, but not everybody has that mindset, and that's why we have jobs. So, with logging and monitoring, you got to have logs, right? You've got to have logs. You got to have auditable events. You got to make sure that when somebody logs into your application, you have that tracked. If you're having failed login attempts, you're having that tracked. If people are attempting to attack your interface, you should have that logged. You should have that being monitored, right? You should have everything and anything being logged when it comes to these sort of high value applications. So if a user logs in at a certain date and time, you should know about it. And if an attack is generated, you should know about it. You should be alerted. And that's something that we test for on web apps. That's something that we test for when we're scanning even networks. If you're not catching me when I'm scanning you, or if I'm sitting there running brute force attacks against you, or SQL injection attacks, or I'm running an active scan with Burp Suite, and all of that's just going through and nothing's triggering on your end, guess what? That's going into the report as you didn't catch me doing this. And you know what? OWASP number 10, insufficient logging and monitoring, right? You're not picking up on what I'm putting out there. So it's important to be able to detect and monitor these activities, especially it says here suspicious activities. And you really need that audit trail. It really helps. From a security perspective, if there's an account breach, it's important to know, who logged in at what time and who was the account that happened during the breach. Was it somebody that got attacked? Was it an insider threat? Who got compromised? And this is all little details that will become very, very important later on, or could become very important later on. And then the monitoring aspect is important. You want to be able to prevent attacks if they're happening, or at least detect the attacks when they're happening so you can do something about it, like blacklist an IP address that might be brute forcing you. So that's the very high level of this, and it should all make sense. The last two should really be like, yeah, that's common sense, right? So from here, we are wrapped up on the web app section. We are going to start moving into wireless penetration testing. I love wireless penetration testing. And then from there, we've only got 2 more sections after that. So we're nearing the end of our journey, but I'm excited to keep chugging along and getting through it. So I'll see you over in the next section when we start talking about wireless penetration testing.
Congratulations. If you've made it this far, you've completed over 2 hours of web application hacking material. If you liked the content, please do consider subscribing to the channel. If you want to see more content like this, we've got a bunch of free courses on our channel, and you can also check our Academy, which I'll link in the description below. We have a subscription to our Academy as low as $30 a month that you can check out all of the content that we offer, including 16 plus courses and the Practical Ethical Hacking course, which you just got a little bit of a sample of. Thank you so much, and until next time, my name is Heath Adams, aka the Cyber Mentor, and I do thank you for joining me. Peace out.